All right, we're good to go. So, welcome to Real-Time Multiplayer Games in Unity. The subtitle might not be apparent as to why, so I want to talk about that. So, this is before there was ECS and Network by default. So, if you guys are in the Unity community and you've been following some of the recent updates, especially 2018 and beyond, ECS, so that's a relatively new feature that Unity is putting out there, along with their job system, the burst compiler, all these neat things that are could be kind of foreign. And I've been in game development for quite a few years, and so you can't just stop on a dime and create a new framework, create games that quickly, since they just released ECS and this concept that they haven't yet put into action, and we'll talk about a little bit more, but that networked by default. I've got a slide where they referenced it. And so, there's performance by default, network by default, and you've got the ECS and all those things that we were talking about. So a lot of these ideas and design patterns, they've existed for a while within, especially within game development communities. So these are not foreign to me at all. But so what I'm going to be doing is, and I'll use James Portnoy's one of his responses to Dr. Ronkai in the thoughts session, or the thoughts section of his keynote speech. He talked about some of the students that were in a very rigorous regiment in his class, where there were these tools and game engines that were put in their lap, and they, James was not going to teach them how to use it. He was going to give guidance on design and certain principles, but he wasn't going to go so far as to teach all the ins and outs of these certain engines. So I'm not going to say that I'm going to go completely hands-off and stay away from some of these nitty-gritty details, because that's probably why some of you came here. But at the same time, I want to say that one of the reasons why I put that subtitle in there was because the latest iterations of Unity right now, in terms of networking and ECS and some of the optimizations, all that stuff we talked about, they're too fresh, and there's just not, I don't have like a lot of details that I could give you about that. And there's so many. The Unity community, as you guys well know, is very broad, and there's a lot of documentation available. So I will reference some of that, and I'm going to try to keep it at a level that will give you insights into how it can be done, but not necessarily exactly how it would be done in all these cases. But we're definitely going to be in the realm of ECS and networked by default, in concepts and things that I've done in the past and the present. So I work at Motion Reality. I see some familiar faces in here. We've met at some various occasions at Siege and stuff, so it's good to see new people and old. So thanks for coming. So let's get right in. So I just want to give a little bit of background about who I am, because you may not understand the context and my experience that I'm bringing, so you can kind of take some of this. So as a kid, I played console games, kind of went into PC games after a while, because I found that the controls and some of the depth in the PC games were a lot more engaging. Sure, yeah. So and it was a family bonding thing. And one of the things that brought games into my household in the first place was my father. He's a computer science guy by trade. He was in the industry for several decades, and then he decided he was going to become a professor. And even before KSU was KSU, at least the Marietta campus, he was a professor there of computer science. My high school summers, a lot of times, were like extended game jams. I would pick up books and figure out how to program and do game stuff and just tinker around and iterate like that. So that's where a lot of my passion comes from. And from there, I went and said, hey, why not join the Army and travel the world? That seemed smart. And the more I learned about it, I said it was smarter to get out and go to university. So any students out there, big ups to you. Keep at it. It's good stuff. And I was also very lucky to be hired on in the industry, not necessarily game development, but it was a very smart guy who was a mentor to me. So I can't understate that. or overstated or whatever. It's extremely important to have a mentor. And I know this talk's not about mentorship, but I just want to say, if you can find somebody that's you find to be smart, who's got something to offer, that's willing to spend some time with you, cling on to them and spend the time. And maybe you can have some great things happen as a result. Like what happened to me. I got a lot of good things that started there. Eventually, over the years, I found my way into the Atlanta game development community. And I worked on some serious games for a while, working on some entertainment-based stuff, and still some serious games currently. And I'm more of a framework guy and an optimization guy. So framework people tend to do network stuff. Framework people tend to optimize things that other game developers are going to make use of. And I enjoy a lot of that for whatever demented reason. And we're going to get into some of the things that I've learned and I feel are useful in terms of real time. Oh, you know what? I'm going to go back here. Just briefly, someone asked me in the game room over there what real time meant. And I just wanted to briefly say, bam, here's what I'm talking about in terms of real time. If you have a video game and things are happening, moving, state is changing, that other people in the game, the other multiplayer, the multiplayer aspect of that, they need to see the same things occurring at the same time, or not necessarily see, but that data needs to be the same, essentially at the same time, then that's what I'm talking about. And that's not an easy thing to accomplish. All right, so your networking backbone options. This is not an all-inclusive list, but one of the kind of main things that you might consider, a lot of the stuff that you're going to communicate in a game, you want it to reliably land where the target is. If the server has something to say, you need to listen and you need to write it down. So TCP might seem like an excellent option for that, because TCP as a protocol has the reliability baked into it, but that comes at a cost. So I do not recommend that. And then one of the other options is a UDP based implementation. Sure, there are others, but one thing I wanted to point out about UDP, it's unreliable and unordered, right? So, but there are things that you can build on top of that, which I'm not going to get into because, like I said, there's certain aspects of that you probably don't need to know about in order to get your job done and create a either like a networking layer for your game team, or just to create a game in general from front to back. You're not going to need to know that because there are libraries that do it. One of them including UNet, right? That Unity currently has as its networking option. But before I talk a little bit about that, I wanted to mention that I follow different crowds in the networking community and different internet technologies. And Google has a UDP-based internet protocol that they call Quick. And it's basically something that they're going to put out there, and it's the new web, and it's extremely fast, and it's a UDP-based implementation, but yet it's going to drive the backbone of a new internet, higher speeds, and it's UDP. So if they can do that for a new internet, you can do it for games and still have reliability and speed. So with UNet, first of all, how many Unity game developers do we have? Awesome. This is excellent, excellent, excellent. So anybody familiar with the UNet APIs, high level or low level? Okay, all right. So I won't, that's good, because I don't want to get too many details for exactly that reason. Probably not too many people have had too much of an opportunity. So they offer a high-level API, and that high-level API, based on the number of hands that just went up of people that have used Unity's networking, if you were to use it, that would be the one I would recommend starting with if you're highly unfamiliar with networking type of code, right? Because it's going to abstract, and it's going to do some of the magic sauce for you. You don't really have to worry about it. However, we're talking about real-time multiplayer games. So I can't say that if you're going down that route, I do not recommend the high-level API. I mean, you might want to start there just to build up your knowledge base, but don't stay there. One of the reasons I'll get to down here in a minute is, guess what? There's no more UNet. they're taking it out. So don't write your games using it. So that's another reason why I can't recommend it. So I didn't go that route because I knew that we, in my position, we write some very high throughput, high data need type of games. By the way, it's where you do motion capture in a large scale warehouse tetherless VR situation where you have up to 12 people, having 23 bones of their body being tracked in real time and communicated out to everybody else, along with the rest of all the game stuff. So I can't put all of that in the hands of some high-level library when I'm going to need to go in and tweak stuff. So we went with the low-level API. So in terms of architecture and authority, you've got client-server, peer-to-peer, which I don't really have much experience with peer-to-peer. It's there are reasons to do it, but I am. You want to, in my opinion, you would want to have an authoritative server. I see peer-to-peer kind of like the blockchain thing, where there's really no authority necessarily, and somehow collectively you're going to have a final decision made somewhere, but that's not my forte. I'm client server, server authoritative is my main experience. And one of the options that you can do is you can have two separate code bases, two separate executables, one for the client and one for the server. Two separate code bases. They may reference some shared libraries, but you could also do everything in the entire server and client space in one code base. And there's a to-do there. I forgot to take that out. However, I did actually check mark on the to-do. So here's what I'm talking about. Here's an example, and it actually does look like maybe you can see some of it. That's not too bad. So this is any of the code that I show, some of it's real, some of it's just condensed example to try to convey an idea. So this is obviously not the entire network transform system, and we'll talk more about systems here in a minute. But the main thing I wanted to show you was the update calls transmit applicable transforms, which is a thing you do from time to time at your tick rate. And I just wanted to show that you've got an is server check. So this is where you've got client code on the bottom, and on the top you've got server code. So one of the things that I advocate as a senior level developer, and I mentor people about, is naming things. So you may see some of the names that I choose, they're somewhat verbose, but it's highly preferable, in my opinion, to have verbose names for things as opposed to comments that can lie to you. But the other thing I was going to talk about was naming convention. So all throughout code, I would highly recommend, if you're going to go the route of combining your client and your server code into one code base, come up with some naming conventions that will keep your sanity when you're true. Because I will tell you this, as long as I've developed, the hardest problems I've had to solve are related to network code. And if you've got client and server interactions occurring within the same code base, you need some things to help you, noodle stuff out a bit. And one of the things that I do is I put an underscore server, underscore client, if it will only solely execute within that context. So that's that. Like I said, UNet is going away. This is the announcement that they made, and it was kind of sad. But I watched the video that they put out about the guy who's writing the new networking layer and why they're doing it and how they're doing it. So since it's not available immediately right now, and you are interested in tinkering around with Unity networking, you can still start messing around with the low-level API. Do not touch the high-level API if you plan on making something that you're going to keep developing and actually put out into the world. Although they will support it, you won't get any new features. So it's gone. All right, so I want to start talking about ECS. Anybody familiar with ECS? Okay, so good. There were a small number of hands and I won't feel as bad talking more about it, because it's a thing that if you go look at any AAA game engine, either that engine provides you ECS support out of the box, or the community is telling you this is how you do ECS. Everybody's doing ECS. And there's some really good reasons for that. And we're going to talk about some of those, because I'm using ECS. Now, keep in mind, some of the ECS stuff that I'm talking about, it's at a level where the concepts do map between how I've done it, which ECS from Unity was not available when I did it, and the way Unity does it, right? There's some things that cross over. But I'm not going to talk to exactly how Unity does it. So ECS is a data-centric architecture. And that's an important thing for several reasons. And in fact, I don't like to describe it necessarily in the order in which it's defined, ECS, because the most important aspect of this data-centric architecture is the data itself, which lies inside of the component, which is why I underlined it. That's where everything starts becoming possible in terms of increased performance and increased flexibility and resilience and extensibility rather, and how you can compose things. So entity. A lot of people, so there's pure ECS, and then there's kind of not so pure, impure ECS. And in a pure ECS implementation, an entity is nothing more than a pointer, or, hey, here's a thing. It's an ID, right? It's similar to an address or a pointer. And the other thing that it's important is that that ID is associated with the data, the important thing that we're dealing with, which is the component. So an entity has, if you're familiar with some of the, as you get more, further along in your career of programming, you will be introduced to design patterns. And there's composition, and then there's inheritance. So it's has-a versus is-a, if you're familiar with those terms. So entity has 0 or more components. I don't know why you would have 0, although I do have one example. I won't bring it up. But either way, it has components. It relates to the data. So the component contains any data items, how much health you have, what your name is, where you're located in the world, any data that needs to be conveyed across the network. That's how I view it anyway, right? So a component can have data that's not communicated across the network, but since we're in the context of networked by default, that's what we're going to talk about. So you can have data that's not networked, and you can configure things and have all these little rules to say, I only want this network, but we're just going to do it all because we're talking about the default case, not the exceptional case. And then you've got your system, and that's where all your game logic lies. So if you take all of that and you map it to what other game engines have done, and especially Unity, if you've been with Unity for a while, this is what you're used to. You're used to saying, hey, on my scene hierarchy, I'm going to start adding game objects. That's the exact same thing as an entity. It's the conceptual equal of an entity. So I did not necessarily put over there that an entity resides in the hierarchy, because depending on your implementation, it might not. But in mine, it does. So the component and the system, you'll notice, they both map over to the same exact concept, the same exact thing in Unity, and that's where some of the problems begin in Unity's previous implementation of what I'll call a bastardized ECS, the game object monobehavior, because you can have data in the monobehavior, and you can have logic. That's how you do it. It's very easy for people to pick that concept up, which is why they made it that way. They wanted Unity to be very approachable, but now the competition in the market to keep them at a AAA level status is to increase their performance. And you cannot get performance at high levels using the monobehavior construct. I don't believe you can. I think you can get some really good stuff, but if you're at scale and at large, thousands of user base, and you're talking about rendering shaders and all these complex things that you want to do to make it look licky and chewy and nice, I think monobehavior it's going to hold you down, which is the whole reason why ECS was created the way that it was done. It's data centric. And I will talk about a little bit more about that data centric nature of it. Because all this stuff is important when it comes to performance and even networking. That's why it's in here. So high performance through data layout. So one of the things that most people do in programming, especially in games, is you would have an array of structures, or let's call it array of classes, right? So I've got a bag of monsters. I've got a collection of these, so we're going to call that an array of structures. That's generally the way you structure your data. So if you look at the top there, array of structs, each individual cell would essentially relate to, let's say, a mono behavior, right? So the red, the vertical slices there would be different. Well, actually, I'm sorry. So the top is more of a horizontal approach, right? So this is basically looking at memory right now. And it reads like English books read, from top to bottom, left to right. So that's what we'll say memory's laid out like. So if you had a red, green, and blue, and a red, green, and blue, that red, green, and blue represents a single game object with 3 unique mono behaviors in the data it contains, let's say, right? So if you had an array of monsters, this is what it would look like if a monster had 3 mono behaviors installed on it. That's how the memory would be laid out in a traditional array of structs implementation. So if you notice, let's say that third blue property of a monster has something to do with its health. That information is scattered throughout memory. It's laid out in a way that requires moving around and doing things that's not linear. Computers, the way that our architecture, the CPUs and the memory, it's faster to compute when things, and look up when things are very, sequential in order. Before we go to the right-hand side, we will contrast array of structs with struct of arrays. And you can see that instead of having a horizontal layout, now it's a vertical layout in terms of what consists of a single monster. A single monster is a vertical slice now. And what that does is when I'm dealing with health and that blue, and I want to execute and look up stuff, now I can, because we've separated, instead of having mono behavior containing both the component data and the system, the logic, we've separated that out. So now we can do computations in a system against a structure of arrays of monsters, let's say. And what that does is now all those health columns are lined up. So if in my system that has all my game logic, I'm doing stuff to invoke damage and modify health and do things with health based on things that had happened, I don't know, I can now do it faster. And one of the reasons you can do it faster is not just memory layout and lookup and sequential ordering. It's because of a new architectural feature on CPUs, which is called SIMD. And SIMD stands for Single Instruction, Multiple Data. So as you're aware, when you do an addition, you've got 2 registers with the left hand, the right hand. Then the operation is add, and then it puts it, so it's just 1 item, 2 item, 3 item. So if you look at the top, we're adding, let's say A, B, C, and D are just attributes and aspects of what a health component data would have on it. So traditionally, before SIMD, and in this arrangement of array of structs, I'm going to have 4 separate operations that are going to be taking place. Oh, and my cursor doesn't show up. Never mind. So top right there, it's 4 separate instructions. Because of the way the memory is laid out, there's just no way around it. You cannot do it any other way. So with SIMD and an instructive arrays, which the job system and the burst compiler coupled with the ECS implementation, but not necessarily ECS inside Unity, but the burst compiler and the job system in Unity will allow for these things to happen for you. But it's kind of a deep hole to go down if you're not familiar with it. But I just wanted to kind of say, hey, it's a thing. One of the benefits of ECS is it allows data alignment so that you can say, hey, you know what? Those 4 things are right in a row there, and I'm operating against all that same stuff. Now I can say monster 2, 3, and 4, and 5, I am going to do that same health operation addition on all of them at one time. So that's pretty neat. That's obviously a 4 times improvement in speed because of SIMD and because of we've arranged our memory in that way. So that's pretty neat. So some key and relevant ECS components that facilitate this networking by default. By the way, when we look at systems, they operate against one or more types of components. So if I have a system so I guess what I'm saying is I don't have to have everything all on the game object and mono behaviors. I can have a system that only deals with health. It's a health system or a damageable system. And these systems will look for a specific component that's on your entities, and then it'll bring them all in and line it up like the destructive arrays, and then you can start doing operations just on the health in that system. But the key systems that are relevant for networking by default would be the network component and the network transform component. And I personally have separated these out. And in fact, in the high-level API in Unity, they've also separated those 2 concepts out. But the network component, as you remember, components are nothing but data. So the data that it holds is a network ID and an authority ID. And we won't talk too much about the authority ID, but the network ID is basically the smallest representation that uniquely identifies that object, that entity in the session, right? And I created that separately from what we saw, the entity ID. In my implementation, that's a much larger number because it's essentially globally unique. And that's a tremendous amount of space. It's 64 bits. Not that cool to be sending that across the network. So these network IDs are much smaller. And the authority ID deals with who owns a particular entity. So if I'm controlling my player, I own that, you own yours, maybe I own my weapon, and then the server can own all the rest of the environmental things that are happening. So that network component, just by having it available and present on your entity, will give you the ability to have everything. That's where the by default comes in for any ECS property change. And the way that you would achieve that will be talked about here in just a moment. As the information is being, prepared to send across the network, you want to, it's going to be optimized in a general purpose kind of way. That's the way I chose to do it. And I recommend you start with a general purpose solution for ECS data changes like that. Because having to go down and bitpack and be very fine-grained and manipulate at a really small level is not that important to start with until you find a problem. The one that I know is a big problem that needs customization comes later. Well, it comes later, but it's in the network transform component. And like I say down on this bullet here, it's highly optimized and customized bitpacking because transforms, at least in the types of games that I've been working with, like your first-person shooters and stuff like that for real time, the network transform is the one that's flying around the most, and it's a large amount of information, and we'll talk about how large in just a minute. But for your general purpose ECS data, like, hey, my health just changed from 100 to 90. I don't need to, spend a lot of time writing a custom message for that. I can kind of do a general purpose kind of thing. And Message Pack is an excellent package that's a protocol that is very, very small, and it's very fast to serialize your data. So if you just create your message, send it over to that, it'll do it. And they've also got an LZ4 compression option, and that is fairly quick as well, and that will get you some additional compression. So that's why I'm saying there's so many things available. Don't go out of your way. So protocol buffers is another one. BSON, which is binary JSON, if you're familiar with the JSON. It's a much lighter weight kind of XML, if I could say that without getting shot, XML. Yeah, XML is ridiculous. So don't put in your game. So let's say, so like I already said, so as far as network transform, if that component is available and on your entity, that means that your network transform is going to automatically get shot around to everybody at a specific configured kind of frequency using a serialization method or strategy of your choosing. I mean, that's basically, like I'm saying, some of these things that I'm saying are specific to what I've done, and we're going to get into some more of that later. Let's see. So, and it also must be accompanied by, kind of like if you're familiar with Unity, requires component attribute. Well, network transform component requires the network component because they go hand in hand. You need a network ID. Because you don't always want a network transform. That's why there's two there. So, component data value changes. So this is kind of getting into how this whole by default networking is going to take place. We monitor those changes, and because we know when they take place, we can send it across the network either then at when it happens, or at some configured time in the future, queuing them up for instance. So on the server, by the way, in the rest of this, in the on server and the on client stuff, the only bit of code that you would actually be writing in this would exist in a system is that blue line. So you would have a reference to some player entity dot his damageable component, which we just take the word component out just because it's, even though I do like to be verbose, let's just say damageable. And then one of the data items in that damageable component is health. And you could just simply, subtract 10 from it based on whatever logic was taking place. So that is all you would write. And then the following things would occur as a result of doing that. And we'll talk about how in a minute. But so we would notice that there is a network component on this thing. And then we'd say, okay, based on the way that my strategy is, I'm going to go ahead and fire this event, this networked ECS event. So the information that I need to convey across the network is something like this. What is the network ID of the entity, which is contained on the network component itself, like we talked about. What is changing? And although that looks like a string, it is not. We'll look, I'll show you some code here in a bit. It's not health. And then previous and new. All right, so that's all the information you need. And on the client side, he's going to receive that, and it's the same data as above, and you're going to be able to find your related player, and then, assign it that new value that was conveyed in the message. So let's get into more of the details of that. So how do you monitor those changes? Here is one implementation, and we're going to talk. You'll notice the class that this thing extends, and it's not a struct, by the way, right? So we were talking about array of structs and structive arrays. Well, that was conceptually to convey information about how memory is laid out, not necessarily that I'm doing my examples in structs. But so this thing is extending a ECS component that's generated, and I'm going to talk about that in just a second. But that'll be important. I wanted to point that out because that's kind of a lot of code, right? I don't want to have to necessarily write. I mean, it's not a ton, but I don't want to have to, every single property in my game, do I have to write this stuff to get this behavior networked by default? No. That'd be very error prone and lengthy and just ridiculous. But this is what the end result would look like, and this is how it works. You're basically just monitoring for the change, and then you create the message, and then you fire the event. And then inside of that event manager, that's where you could potentially have your logic to say, am I actually going to fire this now and send it across the network, or shall I wait till some, planned time? Am I going to accumulate 100 of these so I can bundle them all in one message and then send it, or just single messages one at a time? So, but conceptually, this is how you do it, and that's actually what some of the code would look like. So since we see how we monitor it, we need that to occur, like I said, in all the ECS component properties. So there are far more than just 2 options, but I'm just going to show 2 that I've seen in the past. And one of them, the option 2 on the right, actually results in the code that we just looked at above. So the generation routine spits that out. And so I don't know if that left hand, the OO stands for object-oriented max power, but it's a bit of a bloat. I know that when I first learned about generics, I wanted to use them all the time. But I will say that if you're using generics and interfaces and things like that in high-performance code, this is basically every property change that needs to be networked is going to have this on it. You don't want bloat, you don't want generics, you don't want those things, because you've got type conversions and things like that, and casting that's going to occur, auto boxing. You just don't want that. But this is one implementation that would work, and it would get you that same level of, I don't have to write that horrible block of code every single time. You could do something like that left-hand column, where you create a base class that's a generic that has the type, so you could store anything that you want in it. And then you've got these these getters and setters. So it's basically like a property that checks for the change and does very similar things as what we saw above, but it does it in a way, like I said, that has generics and stuff that we don't want, that'll bloat and slow down your code. So I don't recommend that one. That's why I put bloat up there. But I just wanted to show that there are options out there to achieve the same kind of thing. So real quickly, just for generating the code, you can just identify a code generator. Microsoft T4 templates is excellent. I'll have a link to that in the references at the end. Define your components. You're going to have to do that anyway, regardless of whether you're typing code or creating metadata. You got to say, what type is this thing? What's the name of it? And if there's a default value, right? So you're going to have to get this stuff together. Then you can create a code template. If you're honestly, I can't stress that enough. If you're not familiar with code generation, I highly recommend you look into T4 templates. Highly recommended. You can do a lot of really neat stuff with that. So after you create your code template, you would take the code template and the defined properties, metadata, whatever, slam it over into your generation tool, and then out comes this generated code, and see previous slide. And that's what you will get. So you will have this metadata that lists out all your types, your names, your default values, and the name of your component, and you send all that stuff over, and you get, you get a bunch of these. Okay, so now that we've got that out of the way, we've monitored it. So now, how do we network it from me to everybody else? So this is a condensed version and just a kind of a not nearly complete, by the way, view of what the network system would be doing. The network system would be, so basically, if you look at that on ECS property changed event method, that's basically a handler, right? So I subscribe to a thing at some point in the framework lifecycle, and I want to, so if you look back up here, you see event manager fire event. Somewhere else in the code and initialization, we would have subscribed to it inside of the network system and said, when that happens, I want it every single time, and call this method on ECS property changed event. We would call our serialized method, which, like we were talking about, would be that general purpose one. And you could swap it out later because it's wrapped in this serialized method. So, but for now, let's just say, let's stick with the stuff that's going to get me there faster, and it's pretty darn good as is. We'll say message pack with LZ4 compression is what that's going to do. It's going to give me my byte array, and then I'm going to send it over the network. Now this call right here, oh, I should have put line numbers. Either way, so down in send over network, that's the low-level API call, right, that you would use to actually communicate in UNet today, is the network transport.send. So I've left out some things, but that's basically what you would do. So I'm subscribing to this event every single time any piece of data that's ECS component related changes. I'm monitoring it. I send it. I subscribed, and now the network system is going to shoot it out. Right. So that covers, the server side aspect of that. Actually, it's also occurring on the client because that's a two-way street. So this really, instead of server and client, should say something like, machine 1, machine 2, and others or whatever. So that, 741. All right. So another thing that's really kind of neat about entity system that I found use for, that is, I don't know, I'm assuming other people are doing it. I haven't seen a lot of examples of it, but I can tell you I've received tremendous benefit from doing this. So I say everything is an entity, and it's not just the things that are on the screen. So in a lot of games, you'll have a sort of like a config file that has information about how I want to do this or where this is, the server IP, and this, that, and the other stuff that's like globally accessible. I can now, that's one of my mantras as well, and I highly recommend it, is if you create a framework, and if you're going to use ECS, use it. If it's got auto network by default, just use it, abuse it. Don't rewrite stuff in different ways if you can write it all in a very similar way, because the next guy or gal who comes in, it's going to pick up your code and figure it out. It's one design pattern. That's one design pattern. You can learn it and love it, and the entire code base will be this one design pattern. So I highly recommend that you use it as much as possible. So one of the things that I would recommend is having this concept of the global entity. It is not represented visually on the screen, nor are local entities. But the global entity, bottom line, is basically like a global static singleton of some sort that just holds gobs and gobs of stuff, right? But some specific examples of what it might hold are like a server IP and a port. Now that, for me, and some of the stuff that I've been doing, makes more sense, because it's not like I'm going out to find the server. We know exactly where that server is, what its IP and port is. So for me, that made sense to have in a global kind of static context, but it's an entity. And that thing is defined in the Unity scene hierarchy. That's essentially what makes it stick around. And if you're familiar with don't destroy on load, all of the framework stuff and all the ECS core would be don't destroy on load. So your global entity is going to be in some sort of initialization scene. Anybody use some sort of thing like that where they have a scene that does a bunch of initialization and then goes on to do the rest of your stuff? I highly recommend that as well. And so that's where your global entity would exist with all this configuration data. Now your configuration data, network serialization settings, defining what your assumptions are, your send rate, for the server and the client can be defined there. It's a whole slew of stuff. But you would define it in the inspector, or you could come up with some mechanism that would allow you to store it in a text file and load that and override it, which is what I would recommend. And that's what I did, which gives you the flexibility of making changes to that after your binary build is created and out in the world. And while the server IP did change, that's not going to require a new build, because that would be horrible. Take too much time. So that's a global static thing. And then you got local entities, and I would recommend those as well. So it's kind of like the same as a global, but every single machine participating in the simulation or the game is going to create their own during their initialization period. And it's going to have things like computer IP address, OS platform, account, what type of view do they have? Now, for me, that's important because it might be a monitor, it might be a dual monitor setup, it might be a HoloLens, it might be a VR headset. So other people in the simulation, namely the server, may want to know that, or just your own local client code base might do things differently in your systems, because systems in the ECS pattern is the only place where you have game logic. Bottom line, you shouldn't have it anywhere else. That's why the pattern exists. If you start going outside of that, maybe you could have a helper, sure, but it's the system that's going to call the helper. All of your logic starts in the system. That's how you keep yourself sane. Initialization status, level status. So highly recommended. It's not just about what you see on the screen. You can use and abuse ECS. And all that stuff, like, by the way, level status, the context of this conversation is multiplayer networking stuff, right? So it's not just about the ECS design pattern, but when these values change, like my initialization status or my level status, everyone knows about your status as soon as it happens, or as fast as it can over the network. I mean, it's not obviously going to break the laws of the network you're running on. So I want to give you some examples really quickly. Don't want to spend too much time on this because I really want to open up for questions. And I've got some more stuff to talk about, and maybe I'll leave this up later. But here's some real world examples of some components and some systems that I have used. And the ones in orange are the examples of ones that would actually make sense in a global or a local entity, because we didn't, so game state, network setup, and session statistics. And then the two in green are, or the four rather, the components and systems. Those are the ones that are really relevant to what we're talking about here to get the networked by default behavior. Those components and systems are highly required. So we talked about ECS data changes and auto networking those things. But the other kind of big deal, and perhaps the much bigger deal, is the transforms. Do we need to do anything special to those to get them down to really small sizes? Well, let's just take a look at some of the data here. So we've got a position and a rotation. Those are the two main things that we care about. And so obviously vector 3 for position, and those are all 32-bit floating point values in Unity. The rotation is represented as a quaternion, which is a really awesome thing. I don't know if you love quaternions. You don't need to understand them, but you damn sure should love them because they're saving you. They really are. And one of the reasons why they're saving you in the context of this discussion is the way they're represented. Did I put that down? Oh, it's in the next slide. So I'll talk about that in a little bit better. But the way it's represented is great. But it's 4 32-bit floating point values. So uncompressed as is, even if we had just a out-of-the-box, I'll automatically serialize this stuff over for you, it's not going to compress it. Message pack wouldn't compress it. Message pack, if with LZ4, would compress it, but it wouldn't be enough. But let's just say you didn't have LZ4, you'd be looking at 28 bytes uncompressed. And that doesn't really sound too bad when you're talking, multi-gigabytes worth of stuff in the game, and I can stream Netflix all day. And okay, but that's fine and dandy, but I promise you that is a large number, and here's the reason why. First of all, you want to try to make all of your messages fit, all your network messages fit into one package, if you can. Sure, there are things inside of your network layer you could bake in to take large messages and break them down, but that takes time and effort. And especially if you're trying to associate some sort of reliability with that, it takes even more time and effort. So you want to, where possible, condense everything down to fit into one message. And what is the size of that one message? Well, we're not going to get too deep into it. Look up MTU. It's a maximum transmission unit. And we're just going to say it's kind of low, but we'll say it's about 1,400 bytes. So what can I do with that? So I've got 28 bytes for an uncompressed transform. I've got about 50 transforms that I could send in one message. So what also, yeah, I've got to have a network ID in there too. So there may be some other things that needs to go along with that. Or there's some tricks based on the order of all of these. Maybe I can just assume and understand what the network ID is based on how many, if I'm sending all entities at all times, because somehow I've managed to squeeze them all down into one message, then I already know intrinsically what the network ID is based. So let's just say we're at 50. That's not a whole heck of a lot if you're wanting to do a large game. And that's what we're talking about here. Like I said, if you're a smaller scale, just messing around, or the needs aren't that great for large, high performance, then yeah, you can do things like high-level APIs, and you can do things like, work with 50 entities and uncompressed. It's not that big of a deal, right? But that includes anything that's dynamic. It's not just players. So yeah, 50 players is kind of a lot for one server. That's probably a good amount, right? 50 players in one session. That's good. I don't know what Fortnite has, but you're in a good realm if you could get 50. But that's not all there is. There's a ton more stuff going on that needs to be networked and moving around and whiz banging. And like I said, we've got in our motion capture system, every single player being motion captured in the game has 23 transforms, if not more, or sometimes less, but let's call it 23. So now I'm going to have, what, 2 players and then just or 1 player and a bunch of little things, or not even a bunch, but it's not that much. So there's an obvious answer that, yes, we do need to compact these down a little bit shorter. General purpose just won't cut it. So how do we turn a cow into an ant? Well, there's a lot of different techniques, and each one of these high-level bullet points is what you need to be considering and keeping in mind at all times. You need to increase what both sides know, and make assumptions, maximize the number of assumptions that you make so that you can minimize how much has to be conveyed over the network. For example, this is what I was talking about in the last slide, and why you should love quaternions. There's a funny little property about quaternions that x squared plus y squared plus z squared plus w squared equals 1. That's the identity property of it, and that's the length is 1. That's pretty darn cool because you can now take any one of those, x, y, z, or w, and solve for that using the values of the other 3. And so now you can do some quick arithmetic and say which one of those 4 values is the largest one. And let's get that out. And we can solve for that on both sides. And we can figure that out. So now I don't need to send 4. I need to send 3. Cool. So we cut some bytes out by doing that. Now, I didn't invent this. A lot of the stuff that I've learned over, and this is another reason why I'm not going to give you all the details and all the answers. We don't have enough time, but also it's just ready available knowledge. So I'm trying to give you little bits and pieces to think about. So that's the thing, smallest 3. So that cuts off some. You need to know what the resolution and accuracy needs to be. So do I need to get down to decimeter accuracy? It depends on what you work. If you're working with a large NASA spaceship thing that's being drug across, I don't think you need sub-millimeter accuracy. You might be okay with decimeter, and that allows you to convey even less information across the network. But, you might really need sub-millimeter. You need to know what that requirement is before you make the decisions. And man, 753, gosh. So, and is there a known range of values? If there's not, then I think you need to work a little harder and find one. A common technique that you can use to narrow down and create ranges of data. So you could say, you can convey, I'm in quadrant 10, and then your quadrant 10 is much smaller than the entire universe. So now you can reduce what you're conveying across the network by putting things into quadrants. If you've heard of an octree, that's a technique that could be done for that, like area of interest, things like that. And then obviously utilize the existing compression techniques, LZ4 being one of the main ones that I would recommend in message pack. But so I've actually got I came up with a thing that might be new. I don't know. But if you understand lerping, so remember I was talking about up here in this slide is understanding how much accuracy you need and coming up with ranges. That's going to be important for this next thing. So if you understand lerping, anybody know what lerping is? Awesome. It's a valuable thing to do in gaming when you want to move something from here to there over time. So your input is, your start value, your end value, and at time 0 and 1, and you know what time you're at, right? So you're moving a thing from here to there. either on the screen or just values over time from 0 to 1. And then your output is going to be what that value is at that point in time. So then if you understand that, then you can, will, or already do understand quantization if it's framed in a similar way. So quantization is part of it is what we were talking about earlier. It's like breaking, bringing, reeling in and putting it in a box. So what is your accuracy and resolution requirements, and what is your range? So that's what you will need to know. So I've created this general purpose quantizer that can be used to take those little bits and pieces. So let's say you've got your 3 vector 32-bit floats for your position, and now you've only got 3 32-bit XYZW, one of those, 3 of those for your quaternion. And now you've got to figure out what you want to do to compress that down even further, right? So we're going to put it into a range. We're going to figure out what accuracy or potentially how many bits we want to actually use. So if you know your low end, your high end, what the value is that you want to quantize, whatever happens to be the position or rotation values that you want to quantize, and then you can pass in a number of bits that you want to be represented. So we're not going to say 32 because that'd be stupid. So let's try 16. You may have heard of a thing called a half float. Anybody half float? It's a 16-bit version of a float, and Unity provides a mathf couple of methods that will help you work with half floats. And we're really close to the end, so I'm going to go and I'm going to kind of skip that because that's just a bunch of numbers. It's horrible. So here's actually the code for the general purpose quantizer. Now these are basic, and like you see, they should be made better before you use them in a production environment because they're just not performant enough. But this will convey the idea. So I've got a quantized and an unquantized method. Feel free to do whatever you want with this because I think it is useful. You basically, like I said, you have to know your lower and upper bounds, what the actual value is that you're quantizing, and the maximum number of bits that you want to store that information as after it's quantized. Now, after it's quantized, you're going to have a uint with only the number of max bits up to that max number of bits actually populated. So I don't know if you're familiar with a bit stream, but you can pass in a uint to a bit stream and say only use that number of bits. So that's what this would do. You can't really do anything else with this uint that it returns you, but who cares? It's all because of network traffic we're trying to reduce. So I can take a 32-bit float and turn it into a 2-bit float if I want. And here are some examples up here of what that looks like. And I know we're out of time almost. And so the unquantized does the exact same thing on the other end. So just real quick, and I can't really get into all the rest of the stuff, but this one last thing is the general purpose quantizer. I wanted to show you some comparisons between size, speed, and accuracy, because that's all important stuff. If I'm trying to say that it's a good thing to do, then we need to know what our options are and how does it perform. So like I said, Unity Engine Math Float or mathf has a half float method. I didn't actually mention those out, but if you look at mathf dot and look for half, you will see some methods that make sense. So it basically says, give me 32 bits, and I'll give you 16. And then on the other side, give me 16, I'll give you 32. So I did some different tests. So we started with 16 bits. The version I have, yes, it is not as computationally fast. I did 100,000 iterations, and we've got about a 2 millisecond increase for 100,000 of these things. Are you going to be processing 100,000 per frame? I hope not, because your frame rate's going to suck using these methods, which is why, again, you might need to go do some other things. But if you've got, I don't know, 1,000 or so or less, I would recommend considering this, because what you can do, if you take a look at the average diff, you're dealing with 0.08. So that's after you've unquantized it and you've saying, I'm putting it back into its original value as best as this method can do after it was sent across the wire. So using mathf float, no matter what value ranges I was passing in, it was always 10 times less accurate than the general purpose quantizer. And guess what? It can't even compete when you want to go down to 13 bits or 8 bits or 1 bit or 2 bits. Like I said, you have that ability in that general purpose method. So things like this will help you. And we're at 8 p.m. There's nothing else in here. So I don't mind staying a bit longer. I want to answer questions, but anyone who needs to leave now because you got other plans, thank you for coming. It's been cool. And I've got more to say, so we can talk later. I'll do questions, whatever.